Oh, it feels good. I've been trying to immerse myself into Plutus.
Yo, maybe
And
maybe we'll talk you into sticking around.
uh,
Alex, what's going on? You still in Egypt? Oh, I'm not getting sound from you for some reason.
Now, can you hear me?
there he is.
Better. That's good.
Yeah, there's mute on the phone, so I forget about it all the time. Well, yeah, I stay here for a while, couple of months, maybe 4 months, depends.
Okay. But it seems like you're having a good enough time.
Well, I can work. I have to live with on my parents' couch for now. That's not very comfortable, but otherwise it's good.
Couch life. Wait, so your family has a place down there?
The place belongs to my father's friends, so we can rent it maybe, or I don't know if they pay actually or something like that. But we can stay here, and yeah, it's cheap rent. You can rent an apartment for like $300 a month, and easy life. Don't have to spend much money. You know, good place to chill and escape the horrors of war.
For real, man. Seriously, I mean, it sounds like this is the next Lisbon or something.
Yeah, it's a nice place actually. A little bit, you know. I'd prefer to be cleaner places are more expensive. Here you walk on the streets, there is trash, you know, the houses are kind of beaten up by desert storms, and you know, it's like, but it's a cheap country, it's nice to stay here. A lot of Israeli people come. I had some lessons for kite surfing. It allows me to make some small dollars, small Egyptian pounds actually. Yeah, so it's like I can stay here for now, it's nice.
Glad you're there, dude.
Yeah, I can work. It's nice. I've been digging into this. I'm almost. Actually, I found a good lead, and the guy from Nix forums, he had suggested that Nix can build a Docker image of everything, anything. Just as like specific tool inside, you provide it with the file, and then you just need to run the software that you need, and then you just ask Nix to build a Docker container, and you load it into Docker, and it runs. And now I'm almost. I'm adding Haskell to the build, and then I will add Haskell dependencies, and yeah, it's gonna be just a web server in a Docker image clean for. I don't know. I have to look at the tool that you sent in the morning. It has to be probably everything we need, yeah, to deploy this example validator.
You know, you put that tool on top of it, that ability to work from a web interface, which just makes it so much more accessible for people. It's pretty exciting.
Nice.
Keep in mind as you're documenting this, yeah, I think that this can be the documentation you're building right now can really be the start of a Dandelion PBL.
If you can be more specific, it would be awesome.
Yeah, so showing how containers work.
Okay.
And showing a Docker container in the context of a Nix service. If we show people that first, it's going to make it easier for them to understand what Kubernetes is doing and how Dandelion is serving this purpose. So, right, we start there from kind of a known problem.
Yeah, so it's like we can run any web service in a Docker container, and then Kubernetes, if you ask it nicely, it will take care of the problem when like you have a very popular service suddenly and a lot of people come to use it, and it scales it automatically.
Bingo.
Okay. Yeah.
Bingo. And if you guys, as you guys build this, Dandelion is then a deployment option for sharing a service like this.
Oh, nice.
So
Yeah, that's awesome. So like, yeah, we will have tools, for example, yeah, any app on Cardano that will become popular will need this for sure. And what we will have, but the tools will change with time. And maybe I think Plutus apps is a very unwieldy tool with this. It takes a lot of space. And I
yes,
don't know if it's like, yeah. So maybe, I don't know. I don't understand how it works, but maybe, yeah, having a service that provides like Plutus apps web API,
Yep.
and then everything like, for example, what Hinson did just to do with the API requests.
Yeah. I mean, and that's the thing, right? One thing at a time. This is taking us that direction.
Yeah.
Cool. Well, hey, welcome everybody. Mix, hey, Curtis, Adrian, Sarah, Trevor Nelson, Sebastian. It's good to have you guys here today. We've got a fun one today. So Kyle was one of the first friends I met in Cardano development, and as Gimbal Labs was initially getting off the ground. We've been through a lot of different conversations together, and kind of a precursor to Plutus PBL and this kind of live coding is what Kyle and Roberto did. What'd you guys call it? Coding on chain?
Coding on chain. Yeah, the YouTube is still up. Go
And so those
watch us
YouTube
putz
videos are
around.
up. Maybe, I
Yeah.
mean, it makes me wonder, I kind of forgot about Twitch. That's not really in my world.
Yeah,
but
we streamed on Twitch. Yeah. But we
that was
we
awesome.
uploaded all the videos to YouTube.
So those videos are up there, but you know, it's been fun to watch the Cardano development community grow and to kind of build upon the early work you guys did here. We don't talk every day like we did for a little while back there, because you've been off there building CardanoSharp, and you can tell folks about what else you've been up to. But we've been talking enough to kind of been dreaming about getting you in here as a guest lecturer sometime soon, and I'm so happy that day is finally here. So thanks for jumping in today. What do you got for us?
So yeah, I'll give you a quick intro to me, my background, what I do in the Cardano world, and a little bit more about what we're going to go over here. So my name is Kyle. I started out in Cardano just very much, 2017, watched whiteboard, typical background for most people, I feel like. And I got into setting up a stake pool during the Haskell testnet, launched my stake pool and have been running it ever since. It was less focused then, is much more focused now around .NET development. So my stake pool contributes to the .NET community in Cardano. I got funded in Fund 3 to create the C# serialization library. So if you're familiar with the Emergo Rust, really DC Spark Rust library, I essentially just ported it to C#. So .NET developers, Unity devs, they have access to the same type of tools. So it's very much like that offline type of library. So we can, deal with mnemonics, derive keys, build addresses, build and sign transactions, stuff like that. And yeah, and that's pretty much where I've been focusing ever since really meeting Roberto and James. So Roberto's the reason why I even went into Fund 3 and submitted that. And that was, so the journey kind of started with Roberto, which, I mean, if you know him, he's very much like he's a big advocate type of person. So, he can be very influential. So, yeah, that's pretty much how I got started and what I'm still working on today. Most current activity is really just around Plutus v2 and getting that supported in the library, so we can start leveraging that type of techniques in Cardano. But today we're going to talk more specifically about SIP 1854, which is multi-sig wallets. I think I want to just kind of try to paint this pretty clear as to what this means, because sometimes, let's see, I'm gonna start sharing my screen. Let me know if y'all can see it. Okay, cool. So even in my own community, I have to make sure people understand and keep this clear in their heads, because a lot of times people say multi-sig and what they mean is multi-witness. That is a very common confusion. And I do my best not to correct people unless it is pertinent that we understand and we are talking the same language. So just to be clear, multi-witness is a lot of times what you see with like trades, right? If you're buying something, it's the concept that you're going to put in what I'm buying, I'm going to put in my funds, and it's one transaction. That's multi-witness. What we're talking about today is multi-signatures, which is one wallet that requires more than one signature to release the UTXO for spending. So it's a joint account essentially. Here's the SIP. If you want to read more about the motivations and kind of the spec and what we leverage, more specifically, this SIP is actually a lot to do more with how we can use mnemonics to derive the type of addresses that we would want to use in the multi-sig script itself. Multi-sig uses native script, just like minting policies. So it's the same type of tech. If you can write a policy script for minting, then you can write a policy script for a multi-sig wallet. I might call them joint wallets just to kind of, I feel like it's a good picture. If you have like a joint bank account, you would definitely understand what I'm saying. All right. So anyway, I'm not going to here. I'll just put this in chat, maybe if I can get there. All right. I don't know how to access chat once it goes away. Oh wait, never mind. Just kidding. All right. So that's the SIP that we are discussing.
And Kyle, were you gonna? That kind of blew my mind last week when you pointed to where the SIP number is represented in address derivation. Are you going to cover that today?
Yeah. Yep.
Okay, cool.
Yep. It'll be a little more in the form of my library that
Great.
I maintain, but essentially, yeah, we'll dive into it. So a little bit more background on the technology that we're going to be using. It is C#. So if some of you might be familiar with it, ultimately it's a general program language, typically used for like APIs, background services, and like Unity. It's their main language for Unity. So, but yeah, so here is the GitHub for where all of the stuff that I'm using today, you can find it, including the example. Making our way through. So Cardano wallet, CardanoSharp wallet, this is the main serialization library. So this is where all of the underlying let's say functions for mnemonics, key derivations, addresses, transactions, all that stuff. And the CardanoSharp Jupyter repo is my effort to not just help people learn the library, but give an interactive on-hands way of doing it without really having to dive too far into setting all the dependencies up for what sometimes might be for more of .NET development. So you can just tinker in VS Code. You don't need, I think the only thing you really need might be the .NET SDK. So you can execute C#, but that's really about it. All right. So I have the Jupyter project open here. I have put together a multi-sig example. Just high level, what we're going to go over is first, we're just going to discuss the concept of the mechanics that it takes to set up a multi-sig, which is not a realistic example. And then we'll go over more of a realistic scenario of how it actually would work, not just like, hey, here's a big laundry list of code lines. And reality, this type of process is very disjointed right? Because we're talking about one, we need to build a transaction. We need two people to sign a transaction. And then we have to put all of that together for a submission. So the first example won't do that. It'll do it all in one. But I'll show you how you would do this with that more realistic approach. All right. So what James was talking about earlier was where the multi-sig piece really gets its influence in what you're deriving, right? So if any, all right, I'll just speak as if people don't typically do what I do. When you derive, when you have your seed phrase and you want to derive keys, right, you have a derivation path. Typically that derivation path is in the form of some things I closed out of. Give me 1 second. This won't take me very long. All right, we have this path, right? So we have, which typically actually is this. So this is probably one of the first SIPs that was ever actually approved, which is how we derive our keys, right? We start with the purpose being 1852. Past that is all the same. This is the only part that is different for multisig. So 1852 is how all web wallets and general like Cardano addresses and anything that you're using a seed phrase will derive keys from. More specifically, I mean, you might have known of like the policy ones, which is for doing policy, which you could use that for at least a piece of this. But when it comes to the impact here, we use 1854. All right, it's just that one little change will give us, yeah, so NAMI wallet, they would use the 1852 to derive your address, right? So more specifically, they are actually just doing this path right there. So when you sign up with NAMI, this is the path, this is the exact path that they're going to use. Anytime you create a new account in NAMI, they just increment this first 0. And yeah, that's the only thing that's why you don't get like Daedalus or Yoroi or Eternal, where you can get multiple addresses. So when they do multiple addresses, they are incrementing this 0. That's known as the index. But yeah. All right, so that's the key difference. It's really just this purpose, which I guess is the intent of why we are driving keys. All right, I'm not going to close it out now. All right, so, and we can denote that. Now, this is going to be very C# oriented. Things will be written in models. They will be, it's very imperative. So if you are a Haskell or Plutus developer, you're not going to see functions, not the way that you're used to. These very much are lines of code, not like concatenating functions. So we can see here that I'm starting off with 2 wallets. These are going to be our 2 actors that need to sign the transaction to release the funds. So the first thing we have to do, though, is build a policy, a native script policy around what it means. What are the rules of our multi-sig wallet? So we have our 2 actors. They both have their mnemonics. So again, if you have questions more around the library, I can touch, let's kind of ignore that stuff for now. I'll try to do my best to illustrate what the lines of code are doing. I'm more than happy to answer questions more maybe at the end. So all these, so we have 2 blocks of code. They're essentially doing the same thing. They're just doing it with 2 different actors. So we have 2 mnemonics. I'm deriving the payment key, and then I'm deriving the stake key. This is just for ease of use, but what I'm doing is I'm just storing the public keys into their own variables. It's more for clarity than anything. So what I'm going to do, and by the way, anybody can do this on their machine by checking out the repo using VS Code. You just need to install the .NET Interactive extension. Again, this may require you to download the .NET SDK. If anyone needs help with that, that is a very simple thing I can help you with.
Yeah,
Right.
I can confirm that too. I needed to get the SDK to use this.
All right, cool. Which again, it's just a simple download install. Again, if you're on Linux, Mac, Windows, .NET, as of modern day .NET is cross-platform. People typically, when they think .NET, they think .NET Framework, which is like old school .NET, where it was Windows only. That is not the case these days. Actually, most of my underlying library was written on a Mac. So just fun fact. All right, so I'm going to go ahead and execute this code. We can see it compiled. I'm not really outputting anything here. Just at the moment, it's not very important. So the next step is we need to create the policy script for the multi-sig. And what we're going to say here is it's going to be an all type of policy, and it's going to require 2 particular key hashes. And then that's it. We're not going to worry about validity before or after any type of slot. But ultimately, if you have written these things, you understand how flexible they can be and how many rules you actually can apply to this type of setup. I have a little script here, which, one second. Okay, this is testnet. I just remembered I was doing some testing on pre-prod, and I remember the resetting. So hopefully luckily we won't run into that. From here, all we're doing is we're taking our public keys and we're just hashing them to get that key hash. So we're doing that for both actors. Here is our way of building this down here. So it's just nothing more than a script all where we're setting our 2 key hashes. It's just a builder pattern, but ultimately we got our policy script. Now, the one thing for this, since we are using a delegation style address, is we actually have to build the policy for both. I'm going to put an asterisk on my statement there. That may be false, but I did it anyway because from our initial testing, I remember having to do this. But I might have found some ways where that I might have been confusing myself in the early days. So ultimately, I'm just doing it with both. I'm going to go ahead and execute that. We got green check mark, so we're good. Okay, yeah, no, we need both, and this is why. If you're used to, or if you've ever created a delegation address, which sometimes is known as a base, I would say normal crypto users, they just think of it as their address. An address has 2 parts. It has your payment key and it has your stake key. This is important because if you've ever seen somebody ask the question of, hey, if I use a different address and send ADA to it, do I have to redelegate that stake? The answer is no, right? Everything's automatically delegated. And it's because the stake key is common across all of your particular accounts. At least the standard states that's the way it should be. So the stake key is always the same. And hence why we have to do that. So since we are creating a multi-sig wallet address that can be delegated, we do need to create, this is why the policy script for the stake was important. So what we're really doing is we're taking the, now just, I want to point out payment script. All right, so we have this script for both the payment and the stake. So this is very similar. Ultimately, the actual construction of the address doesn't, it's not really too different from just basic keys. So I can go a little bit more into the weeds there later if somebody's interested, what the difference between constructing an address for basic keys versus the policy scripts. But ultimately, combining all these things, we'll get our multi-sig address, which we can go ahead and check that out, which you'll essentially see some previous testing, but it'll be okay. We're gonna redo it all anyway. Oh wait, no, not this place. Testnet C Explorer. Yeah. Cool. And you can see I've been doing some testing, but ultimately we're funded. It is an address that looks just like normal. Some interfaces will actually tell you that this is a contract, which is good. Before pre-prod and preview, Cardano scan. I mean, if we were on those networks, they would show it, but they will actually detect that it's a contract address and not just an address. All right, so we have our multi-sig from our policy scripts. Step 4, all we're going to do is what you would typically do with ad, right? In order to spend, we have to make sure we have funds. So what we're doing here is I'm checking the balance, but I'm showing you something about the address and how it differs, which is kind of just more or less that is contract piece. So I'm just using Koyos under the hood. Again, .NET developers, I also created the Koyos C# SDK. So that is my preferred online library for retrieving information from the chain. So we can see this one, just to be clear, from we output our policy. This is the same. I don't know if it's okay. It's not going to, but this is the same address that we showed up there. And it is actually able to tell us that it is a script address. I have a normal address, so you can see that's not a script address. But that is from the Koyos API. It's just a Boolean basically saying whether or not it is a script address. So Koyos can even identify that for us. All right, so the next part is going to be the full example of building a transaction, signing it with these 2 keys. So if you're familiar with building transactions, if I said that you're going to send funds from one UTXO, so you only need one input, you're going to assume, if it's just a basic transaction, that you're only going to need to sign with one key, right? The one address that generated that address, or sorry, the one public key that generated the address, you're going to use that private key to sign it. Since our policy says that we need all of the actors to sign, you will see that there's actually 2. And what I can do is I can remove one to show you that it fails. We're going to do a lot of failures, and we'll kind of work through that. So I'm going to point out the important bits here. There's a lot going on. So hopefully this doesn't scare anybody. But ultimately, let's just say, okay, so from here, this is just creating the body. We're declaring some outputs. We're doing some inputs, just using basic SIP2 coin selection. We are gathering our protocol parameters. We're setting our fee based on that type of stuff, which that is not up to date, but we're gonna ignore it for now. Oh wait, just kidding. Never mind. We have it down here. So anyway, from here, what we're doing is we're just calculating the TTL, basically how long we want the submission of the transaction to be alive for. And this is the part that's important. We have to add our policy of what the contract is. So we can add our policy here. And we have our 2 actors signing, okay? So we're just adding our V key witnesses, and ultimately under the hood, when it serializes the transaction, part of the serialization process is to sign the transaction, essentially, if it's present.
Ooh, hey, Kyle, can you zoom in just a little bit to make the text bigger?
Yes. One sec. How do I do that with?
Just, I think Control+ should work.
Oh, Control+. Okay. There we go. Cool. Like scrolling. All right. Is there any? Okay. Yes, I have the chat. I'm trying to make sure I pay attention.
I got you. You focus on this.
All right.
I'll jump in.
All right. So here we're just calculating, anyway, we're past that. Sorry. We've added our signatures. We are building the initial, we're constructing the initial transaction. Note that this transaction does not have any type of metadata, any type of aux data whatsoever. So we just have a body and we just have signatures. We're going to go ahead and build it, and then we will calculate the fees. This is actually a little unnecessary now with some new updates, but it ultimately will work. And you'll see what I mean by some of the updates. We're actually going to leverage them in the next one. We set the new fee. We have to calculate from our change, yada, yada. And then we're just kind of outputting what the signed transaction looks like in CBOR. Not really important. for us right now, but it is really good. Basically, if you're working through this, taking something like this and using, in case anybody has ever used cboard.me, it's a very useful tool to decode your cboard and compare to make sure like you kind of can dive into what your transaction looks like. So I'm going to go ahead and run this, and then right after we're just going to submit it to Koyos, the testnet, and hopefully we'll get a success with a transaction ID. All right, so we're making a bunch of calls to Koyos, building a transaction. Koyos is a bit slow today. There we go. All right, that took way longer than normal. 1 second, let me just rerun that again. There we go. Okay, figured I had to do. There was probably some cold booting that needed to happen. All right, so from here, we're just going to take that raw transaction. We're going to serialize it, which at least in this way, it's the same as signing it, and we're going to submit it. So I'm going to go ahead and do that. Cool. So we have a transaction ID. So that was successfully submitted. Really, I should be able to see it on this, but this might take a bit. We can just sit. Oh, okay, there we go. All right. So now I will say one thing about this particular interface. I'm going to show you guys something that I find important, but I will say I've only been able to find it on the initial transaction. I haven't been able to see it on subsequent transactions. So at least on the first one, and I've already gone through the verification process, just to be clear. It has been able to identify that this is a contract, at least a native script contract. So you can see, and this is the same exact policy script that we were using. So, but anyway. So we'll wait for that, and really it's just going to my testnet wallet here. And you can see we've already received the funds. So cool, it was successful. We'll do more of the failure. In fact, let's go ahead and look at the failure right now. So what I'll do is I'll just submit or omit that. Go ahead and rerun. Run again. Oh wait, my bad. Let me edit this real quick. The result. Something went wrong. Okay, well, that wasn't very useful, was it? Let's see. I think it's comp. Trying to remember where, maybe data. Trying to remember where Koyos hides their real errors. I thought it was content. Yeah, okay, there it is. So here we can see that the witness was not valid. Ultimately, it's kind of indicating that we're missing something. And this, if I'm not mistaken, you know what? Sorry. Okay, maybe not. I thought it was telling me that it's part of the. Is that just the header? No. Okay, never mind. I thought that was the key hash, but it's not. Anyway, you can see that it's just, we are getting that witness not validating. So it's this, once we throw this back in, which I'm not going to execute this because we still need some of those funds for the next example. This is a good, I guess, stopping point. Does anybody have any questions about so far what's going on, a little bit more of the process, anything like that? we can even segue more into like real world examples if somebody has questions about that as well.
Yeah, Kyle, I appreciate that you said this is not the real world example yet.
Yeah, and what I mean by that comes down to this part right here. It's not really realistic that when you're constructing this, that you're going to have access to both of the private keys, right? So let's say like this was like an application where somebody was facilitating multi-sig type of functionality. It's more realistic, and this is gonna be the example in a second, where you build the transaction, you go ahead and serialize it into CBOR, and you're more or less passing that object around for the actors to sign. So, that would look kind of like, okay, I build a transaction. Actor one is notified that they have a signature that they need to apply. They sign it. That signature is sent back or stored however it needs to be done. Actor two does the same thing. Once both signatures have been collected, we re-serialize everything up and then submit. Cool. Awesome. All right, so let's just go ahead and jump into that. Maybe we'll. All right, so everything I've just stated. So this should look very familiar. It's pretty much copy pasta from above. The only difference is here's the first change. So this is really important, right? If you build, admittedly, I don't use Cardano CLI very much anymore because we have another tool that I like to use that doesn't rely on an actual node to be active. But we need to mock, right? Mocking is very important because when it comes to calculating fees, it's all about transaction size. And if you don't calculate fees correctly and you sign, that means you're going to sign something that won't end up being the same, right? Because if you change one little thing in a body, it's going to change the hash of what you're signing. So what you sign is different. So it's very important that we go ahead and mock. And in this particular example, we know that there's two signatures that are going to be collected. So we're going to go ahead and mock two signatures, which will help us with calculating our fee correctly. The next part is, all right. The reason why I did it like this, now I could have just done it the other way, but the other way, when I say the other way, what I mean is this up here. This is using something a little lower level. And in my head, I don't think that any type of application that would be facilitating a transaction like this would be privy to the information at the time. And in fact, I think these are things that have to be provided. So one would need to provide the actual policy that needs to be enforced, right? So it's just like, hey, here's the policy script, make sure that the rules are enforced, right? But the construction of the policy script is what I don't think is realistic to expose. So that's why this is being done a little bit differently. Now, admittedly, I'm going easy mode on myself here. There are definitely other ways to go about this, but I'm just implying that we're being provided the policy script and not that we get to construct it itself. So, but ultimately, not much is different. It's kind of all the same, right? We have an intended output. We're determining our inputs. We're getting protocol parameters, all that stuff. So I'm going to go ahead and run that. And while that's going, the next part is all about signing. So this is the part where in an example where maybe an application is notifying an actor like, hey, you have something you need to sign, right? Ultimately, we have, let's say we are able to deserialize a CBOR, which is a very realistic thing, back into an object or something that is actually readable. We're going to go ahead and sign it. Now, we don't have auxiliary data, right? But auxiliary data does influence the body. So that's just kind of why that's there. Long story short, this is just going to hash out the transaction body. And just to be clear, if anyone didn't know that, when you sign a transaction, all you're doing is signing the body. That's it. Or at least a hash version of it. All right, so from here, we are taking, we're doing the signing in the same little code snippet here, but we're just implying that actor 1 signs and then actor 2 signs. And we'll go ahead and execute that. Cool. The next part is reconstructing the transaction. Now, luckily, there are certain things I don't really have to do again, but really I'm just recalculating the TTL, which luckily we're probably not going to run into a hash difference there since the byte size won't really be different, most likely. And then from here, we're clearing out the witnesses, because remember we have 2 mock witnesses in there, and we want to clear those up, and then we're just going to add in our witnesses that were just signed by the 2 actors. And this can be done independently. It doesn't have to be done with one at the same time. And then we just submit. So go ahead and submit. Something went wrong. Yeah, but what went wrong? All right, I'm going to do this a little faster. Sometimes when I make it too disjointed, it doesn't like to play nice. Or we get the privilege of doing a little coding on chain. Dang it. All right, it was just a time thing, which is fine. But just to be clear, the time issue probably comes down to the amount of consolidating I'm doing and like kind of skipping some steps that in a real application you may want to redo certain things, which I would advise you to do. This is very much just an example. All right, no result yet. Cool. So we can check our wallet again. And another 5 showed up. Same transaction. All right. All right. So does anybody have any questions? That was pretty much the demo. This is a simple demo, right? I only had 2 keys. I see things like this being very useful for basic treasury stuff. Like to me, that's just a basic joint account. You could definitely use these things for like escrow style things, right? So like the cool thing about native scripts is that they're recursive. It doesn't have to be just one script that has some keys in it, right? It can be a script that has scripts in it. So, so like, let's say 2 parties come together, you have a client and a consulting company, right? Like maybe Gimbal Labs is doing some work for some other company. We use a native script basically to come together, and we can hold funds and lock them into this transaction. And they're released upon agreeing of everybody signing, right? So it's a little more traditional approach, but to me, it's very realistic, especially in a more enterprise corporate world where they don't really care about your smart contracts or your crypto, to be honest. All right.
So one question in the chat, can a token that has been minted from a multi-sig address have a single signature policy? For example, can you have multiple signatures, but just require one of them? Oh, Kyle, you're muted.
Yes, if I understand correctly, what you're asking is the difference between all, any, or even to go farther with your example, let's say you have 5 different signatures that could be on there. It may not be realistic to say like, okay, well, we need all 5 people, but it might not be secure enough to just say just one of them. So they have the N of K, so you could designate saying 2 or 3 of those 5 signatures are required.
Can you just show us where all is in that policy ID that you were using a moment ago?
Yes. In fact, let's do an example.
Awesome.
All right, so just for the more JSON oriented, it's this part when we describe the type of the native script. So that all. So what I'm going to do is I'm going to change this to any, and we're going to omit that one signature that I omitted before that caused an error, and we're going to see that there's no more error. But let me also check one thing. I want to make sure we have a balance. Okay, we're good. So I have a few places I need to change this, but essentially it's, at least for us, it's as simple as changing this. Do. Go ahead and rebuild that. Cool. All right, so this is going to change our address as well. Yeah, I need to fund that. Give me a second.
And so just to put a point on that one, right? Even if I have, say, 2 addresses and each of those pub key hashes is in a script, just changing the word all to any is going to change that address.
Yeah, because
right?
That just because you change the JSON essentially, right? So when we hash the JSON, you change just a little bit, it's going to give you a different hash.
And so anybody who's experienced with Plutus, and you recognize that if you just change a single validator parameter and you get a different address, this is a similar thing going on here with native scripts.
Yep. Let's go ahead and run this. Hopefully Koios is caught up. Yay, okay. Is that the same address? Yes. I'm just confused by the balance. Sorry. Maybe.
By which part?
One second. The balance. I mean, I'm not putting it past myself to. Okay, this might be really old from when I was doing initial testing. Okay, let's see. Yeah, okay. So when I originally developed this feature in the library, I was using an any. So we're just kind of piggybacking on what I already wrote back in the like back in July. But yeah, so but let's just prove the point, right? Right here. So what I'm going to do is I'm just going to omit one. Now, before Curtis has a question. Oh, yeah. All right, so I had to change the fact that we're setting a particular type of script. We're only sending in one because we're saying any. Go ahead and serialize that up. Submit. And cool. Yeah, okay. This is an error because there's no error. Gotta love it. That will eventually pop up. Cool. And there we go. Once again, we received our 5 ADA, and we only included one signature there due to the any type. Okay. Oh, I guess there's like questions in Discord, right? Is that what's going on?
No, I got a private message with a question. But yeah, Curtis, Jonty, and anybody else jump in with hands up. I think that's the next place.
Yeah, I was just curious. Sorry, go ahead, Jonty.
No, I was saying go ahead.
Yeah, I was just curious, like when it comes to building the transaction, if you have n of m, and let's just say n is I need 5 signatures out of the 10, and you receive 7 signatures, I expect that to fail because the transaction that you built has the necessary fees to cover, let's say 5, because that was the N of M. But how do you, I mean, you can't predetermine that. So would that transaction fail? And is there a way to actually build a
Yeah,
transaction
it's
when you don't know how many are signing it? Sorry, go ahead.
yeah, no, it's a great question. Ultimately, you just don't include the 2 extras. You just got more than you needed. So it's kind of more like a threshold. So like once you get 5, submit. You may get more, but you don't need them.
Oh, okay. Okay.
Yeah.
Well, shoot. So that doesn't get those 2 that get dropped are not written on chain. Therefore, if you were to like query who signed these transactions, they would be missing, right?
Yep.
Okay, cool. All right. Thank you.
Yeah,
We had a really, sorry, Jonty, just real quick. We had a really great live coding session a couple months ago where we were looking at how to add witnesses to transactions that way. Let me find that video and we can dust that one off later this week too.
yeah, thanks, Kyle. Janti here. For the multi-sig, the issue I see is because I had tried to implement this for a group of people managing the DAO. The challenges was to actually confirm the transaction we are sending. And again, the CBOR checksum, that will work, but it's quite too technical. It would have been good if a wallet, the same way they show you how much you're sending, if they could even show you some elements as to what actually you are signing. Yes, you see where it's going, you can see the amount. Actually, at the end of the day, somebody who knows how to read a transaction will know what it is. But is there a way we can make like wallets that will be more useful for multi-sig to know what is the transaction, how many have signed, and who remains to sign? So that would be useful.
So yeah, no, that's very important, and it depends on your underlying capabilities. I will say with the C# library, you can do that because we have serialization and deserialization capabilities. Ultimately, if you gave me some CBOR and you told me it was a valid transaction, I could deserialize it into my C# objects and build interface around that, saying like, okay, here's the metadata. That's probably what's the most important. And you could analyze that native script. So here, let's kind of look at a little bit what I'm talking about. It might help.
Yeah. From within the wallet, yes, but you know that there needs to be a trusted source of that confirmation, because you cannot just, you could see it and not trust it.
And the thing about it is there is a level of trust, right? For non-technical users, they have to trust the software they're using.
Yeah.
And if you don't, then it's like use something else or learn what you're doing a little better. Yeah, it's one of these things, crypto, it's like, oh, we live in a trustless world, except when there's software layers involved, then that doesn't apply anymore. So right here is the actual that's the native script itself. So if we wanted to, given this, and ultimately we don't have any auxiliary data, but if I had metadata, we'd be able to see that in its CBOR form as well, which we could go a step farther and deserialize that part. And all these are essentially byte arrays in string version. So if you have your key, or let's say you have your public key, you can you can make sure that your public key is actually in the hash, right? You just take your public key, Blake hash it, and there's your key hash. You can make sure that you are in there. And the even better yet, and this is, so we can get into more DAO stuff, but that's kind of my next venture. The way I see this going down is if I wanted to verify all actors in this, if I have your DID, right, a DID document of your public key that is used in the native script, which very much that would be probably a security thing to do. That way people could verify your role in this process. We can grab all the necessary transactions where our DID documents reside, take those public keys, hash them up, and make sure that they are all in the native script to verify that the native script is not malicious. So that's one way to ensure the validity of the native script itself. Past that, to me, it's more about understanding maybe the metadata that is going to hold and the output. So maybe let's say you're trying to execute a smart contract, like a spending script or something. Or let's say you guys were just all signing off to create a script reference. Those are things you could also verify, given the know-how or maybe the software capabilities and level of trust you have with it. So hopefully that answered the question. But yeah, so I could take that CBOR string and deserialize it.
Yeah, it did.
So
Yeah,
yeah, this definitely ventures into like verifiable proofs and verifiable credentials for the type of security you're talking about.
Yeah.
Which to me, that's the exciting stuff.
I would love to build a web front end. Yeah, that just keeps it very simple. Look, will you sign on this? Spend 50 ADA from this treasury and send to that address. Yes, I do. Click. My signature is added.
I would argue that
Mhm.
I would like to see a desktop app. That way I can turn off the connectivity and I can actually have a cold machine.
Oh,
all
desktop for cold signing. Holy cow. Okay. Okay.
Yeah.
I was gonna give you shit about advocating for desktop
I
apps,
think
but I love it.
I think Web3 is the bridge to like, I don't know. I think desktop and maybe mobile are, in my opinion, this is just my opinion, I think that's the better platform for decentralized applications due to the actual distributed part of it, where I don't have to rely on a central service to host their website and stuff like that.
Once I have the app, I have the software running on my computer now. Nothing can stop me from having that once I have it.
Yeah.
And I mean, and it would be trivial even to make the app force you to turn off the internet to sign a transaction. For example, you could have that as a setting.
Can I ping google.com? Yes. Sorry, this is too insecure.
Yeah.
You can't do it.
Wow. All right. Well, so you're going to have to give us one of your playground lectures in an upcoming Tuesday to dive into that topic. But that's really interesting.
Yeah, maybe I can get Sharp DAO a little further along and we can we can really tinker with it.
Cardano user asks, there seems to be a lot of power in multi-sig and metadata. Why do we even need smart contracts when there's all this functionality? When was the first time we talked about that question?
Yeah, probably right before Gojin really like started getting popular.
Question.
Yeah, no, I agree. I mean, I think it's one of these things where people are, at least in the crypto world, are so adamant about getting smart contract support because it's this thing, right? Like Ethereum is not the same type of accounting model. They don't use UTXOs. They don't have native scripts and stuff like that. So it's a perception. To me, it's just a perception problem. It's what people, this is sort of new-ish. But yeah, I definitely think that native scripts with metadata are very powerful. And if you can walk that road instead of going down a smart contract, one, it's probably cheaper. I know that, and I'm not even just talking about like transaction costs. I know that the fees are getting lower for smart contracts. That's awesome. But just from a development standpoint, this is way easier to develop. I don't have to know Haskell or Plutus to do these type of contracts. Admittedly, they are lower capability. I would love to see more features come out. There have been a few things discussed that I feel like could be introduced, but that's just, I might not be an expert for that one.
That raises two things for me. One is, I think just framing the question differently for ourselves is like think first, how far can I go with native scripts and metadata? And when you find the limit, then say, okay, well, here's a case where I need to use a little bit of Plutus. One example is, native scripts can ensure that these signatures are on a transaction. But for example, if I want to limit or even have a lower and upper bound to how many tokens can be moved from an address, that would be a case where I want to use Plutus, right? And so just thinking about, what do I need here? How am I going to do that?
Yeah, because what you just described, right? That would have to be self-enforcement of the people constructing the contract, or sorry, the transaction.
We could just do in a trusted place, in a small enough circle, we could just agree, okay, we're never going to send more than this. But if we need an extra layer than that, we can put that into a validator. We can only ever spend within these bounds.
Yeah. Yeah, and there are people who leverage this type of technique, especially in the DAO format. Where, and this is the same type of methodology I have about the concept of how you, when I say operate a DAO, run a DAO, I don't mean the DAO side of things. I mean the technology side of things, where if you ever go Google stuff about DAOs, you may come across this concept of off-chain versus on-chain governance. And in my opinion, I think where you should sit is right in the middle. I think that there should be certain things that need to be on-chain. But I also think that there should be certain things that people may want to put on-chain that I think should not be on-chain for a security / doxing / any type of like, hey, I'm going to scold you for your opinion type of thing. And these are things that we should rely on cryptography for. So like the act of voting on a proposal, I do not think should be on chain. I don't think somebody's opinion should be on chain. I think the result and the action taken from the result should be on chain and triggered on chain. So if you think about a proposal, let's just say it's a simple yes or no. You may want to trigger a smart contract based on a yes, or let's say a pass or a failure. These are things that can be done. You can trigger the smart contract from the transaction based on the result. But who voted yes or no, that seems a bit like privacy violation in my opinion, that I feel like people just kind of oversee. They overlook that concept because they're like, oh, it's we're on chain, everything's decentralized. It's like, yeah, and we all get to look at the fact that you voted for that person over that person, even though in public forums you're saying one thing. So these are things that, I mean, don't get me wrong, that would be probably nice to know, but from that person's point of view, they probably don't want them to know that. I can't speak on that. I don't know. ZK, the zero. I mean, to a certain point, yeah. And that walks the road of like verifiable proofs and credentials, which if we can go that sophisticated, where like for instance, you're not just associating a DAO membership to a wallet, but it's more to a identity, right? Where it's a DID document, and you may have, don't get me wrong, you may associate your DID identity. When I mean by DID identity, I'm kind of talking about the private keys that you're signing things with, and you have that verifiable, let's just say V key, right? That people can use to verify that you did sign this other thing. I think that's where those things can come into play. So if instead we weren't signing things with wallets and we were signing things based off of just pure cryptography, which could be managed by some type of SSI agent. And by the way, if you ever hear anybody say SSI agent or talk about agents, they literally just mean an app, like a phone app or a desktop app. It's not any type of special thing. I don't know why they want to call things little. I think it's one of these things where people like to use fancier terms so they can kind of pigeonhole technology and not try to make it open for people to understand.
Always.
But yeah,
we need to build, I would like to build some experiences that help people have stronger opinions about this, right? So for example, how many people, once they see it in practice, might go from saying all votes should be on an open ledger to maybe just having a more nuanced opinion than that. It would be interesting to build some experiences.
Yeah, like I would be more comfortable with my vote being on chain if it was through a DAO membership document. Because for instance, if you just think about the concept of DIDs, they themselves are decentralized, right? If like for instance, you may have a DID document just stating that you're over 21, and that's all it does. Like, you're right, the issuer gave you your credential and they verified that you're over 21. It doesn't have your age in it. It doesn't have your name or address or anything like that. So anyone who trusts the issuer, they can reliably trust that the credential is that you're over 21. That's all that needs to know. The same thing could be with your DAO membership. I don't need to know who you are to know that you're part of a DAO. As long as the DAO let's say the DAO is the issuer in the stamp, as long as they are okay with your DID document and they want to issue your credentials under that, you're anonymous-ish to a certain point, at least to the public. So yeah, no,
It
this
can be a
is
voting parameter, how much information needs to be shared. And people might decide for this vote, we do want to know more about who voted what. I can imagine scenarios where that's the case.
Yep. Trevor, you want to jump in with your question?
Yeah, so first off, super cool. Really enjoyed the presentation. I didn't know about CardanoSharp before today, so this is like really fascinating. Got my mind moving. Following that up, I do have a question. You'll have to be a little patient with me. Unfortunately, I've had to kind of multitask today, so if I missed something, I'm sorry if I'm making you rehash it. But
All good.
it looks like you mentioned the desktop application, and you mentioned that the .NET framework isn't a Windows only thing anymore, and all that stuff, which is awesome. And mentioned that some of this stuff could be used in a desktop application even off chain. And it looked like, correct me if I'm wrong, for submitting currently you were using Koios.
Yep.
Awesome. So as far as like the .NET framework being used outside of Windows, all these other things, like I've even seen there's people you can compile .NET to microcontrollers like the ESP32 now, and so I'm just kind of curious, how lightweight can this be? Like, do you have the option of putting this on, say, like something really small, like a Pi Zero single board computer, and being able to sign transactions out of something that'll like fit in your pocket,
Yeah. I personally have not done IoT type stuff, so which generally is what those mechanisms fall into.
Yeah, for sure.
I will say that the people that I have worked with that have at least shared their experience with it is one, right, you're just going to want to have the runtime, so that'll greatly, oh man, if I could you're asking good questions that I don't have answers for, hard to answers for. But I know like the binary is getting smaller for release to release. .NET has at least over the past 4 years have been four, yeah, we'll say four, have been focused on their cross platform capabilities and for improving their benchmarks with their compile sizes. I can definitely find some answers for that. But yeah, I know of people who have run them on Pis and Arduinos and with no problem at all.
Awesome. Yeah.
Yeah.
You don't have to have hard answers for it today. I was just kind of like my brain's just moving on it now. Like I hadn't seen this before, and I'm not a C# guy, but I see it everywhere. So this is just really, really fascinating. I'm just kind of curious. I appreciate it.
Yeah, a lot of the, at least let's say, platform work that I've done. So like my capstone project for Fund 3, me and one of the other developers put together a hybrid mobile app using Xamarin, which today is called Maui, multi-platform user interface application platform, something along those lines. I don't know, Maui. But it's one of these concepts that they've been investing in, where you have one code base. So, and just to be clear, like I feel like what they did was they just looked at Unity game engine and were like, if they can do it, why can't we with our own tech? So with Maui, I can write something and deploy it to iOS, Android, Mac OS, so Mac desktop, and then Windows desktop. It blows my mind that they refuse to support the Windows phone, but I feel like they've accepted their own fate on that one. So, but yeah, so that's where I think things are very, very interesting, especially now. I will admit right now, now this is another side of .NET that we are very close to providing, and this is one of my goals. And between talking to Roberto and admittedly, I don't remember his name, but the game changer guy, they've been kind of hounding me to produce web assemblies for them. Right, where it's because ultimately right now the one WebAssembly that we really have is kind of like a full suite library of everything that you can do. And one that doesn't, unless you're a Rust developer, you're not going to be able to customize it too much. You're not going to be able to like maybe build in some business logic you'd like to put in there or some rules. But we are, I think, basically .NET 8, which will come out in about a year. We should have, or hopefully .NET 7 will get it, but there's one particular cryptographic library that we need to be supported in the WebAssembly for Blazor before I can start producing at least a library for people to compile their own WebAssembly for their own use cases. That way they can, like, maybe you don't need transaction stuff, or maybe you just need like mnemonics and basic cryptography, right? Like something like you're describing. Now I don't know why you'd use WebAssembly, but whatever, just an example. You could produce your own WebAssembly that has your own functions to do specifically what you need it to do. And no longer do you have to just use the general package. So
Awesome. That's some crazy cool stuff. Thanks for sharing.
yeah, absolutely. Yeah, and if anybody I'm gonna give a plug.
Yeah.
While I have
Just one other thing while you're pulling that up, one other thing that I was thinking about before when we were talking about moving from native scripts to Plutus, you're able to create a script hash for a multi-sig native script like we created. And that hash can be used in a Plutus contract, right? So the thing that I haven't played with yet, and if anybody wants to play with this, I'd be interested, is how do we take that hash of a multi-sig script and use it in a Plutus contract by using the message signing standard, right? This validator only validates if the script is already validating because it got the necessary signatures, for example.
that would be fun.
Yeah.
I honestly don't see any reason why that wouldn't be possible.
Oh yeah, it'll work. We just have to make sure we know how to do it. So that's something to be playing with.
By the way, Trevor, were you hold on. I may have to give you a big thanks. Is this you leading this video? All right. This video,
yeah.
So this video has actually been a godsend for me. Trying to build Plutus script support for the library. It's one of these things where like I don't need to write Plutus or do any of these things. I just need I need the transaction CBOR where like the references, the datum, and all that stuff resides. And for the longest part, I have not been able to figure out a good quick guide to just get me to that part. But yeah, that video, that was very influential. I don't think I would be as far along if it wasn't for that video. So awesome. I appreciate your work.
Dude, thanks for saying that. Honestly, like wasn't sure that was going to be super helpful to many people. So I'm glad that that's been beneficial.
Yeah. All right. Anybody else got questions? Cool. I put my Discord link in the chat. If anybody wants to join, follow. I mean, if you see me in there, my name's not Kyle, it's Noah Mason. Send me like just hit me up. if you have any questions, whether it's .NET or Cardano or how they both play together. Always happy to do my best to answer those questions. So
Kyle, thank you. And I pushed the Plutus PBL role on you in the Gimbal Labs Discord as well, so it's easier to track
I've
you down.
graduated.
People have questions. Thank you. So one other thing I'm thinking about, and this is what Alex and I were talking about as people were showing up for this meeting today. We're starting to dip our toes into services that could be deployed via Dandelion. So Alex and Hinson, I've mentioned this to some people, are working on a service that takes a parameterized validator, exposes an endpoint that allows you to submit parameters for that validator, and it gives you back the CBOR and the address. It's going to be a really helpful tool. And that's an example of something that anybody can create their own instance. It's going to be a containerized service, but this is also something that could be served on the Dandelion network. And so things like this, you know, I see CardanoSharp really supporting us, even if we are primarily building, say, on a Next.js project for the front end. And even if Mesh does some of the functionality for us, we might find that we want to deploy a container with the .NET service in it that allows us to handle multi-sig transactions. So for anybody who's starting to put these puzzle pieces together in your head, I would love to do some explorations in that. And you know, maybe a project to tackle is this, even if it's not living up to Kyle's hopes of having a desktop app with that for use on air-gapped machines, even if we don't deliver that first, but we do create the ability to send a partly signed transaction to somebody else and have them in a simple interface see what they're signing. I think that's a really good proof of concept. So if that's the kind of idea that lights anybody up, let's be in touch about that. And I'll be thinking about how soon we can put that on a bounty board. Do we have anybody here with .NET experience?
Hard no.
I've been surprised by how easy it is to pick up. Yeah, it's not. Actually, maybe the hardest part is that it's similar enough to JavaScript to confuse me, because I can start to forget what language I'm in, and there's just a couple of little differences, but it's
Yeah,
pretty approachable. I think it's like learning French if you know Spanish, I think.
yeah. If you know TypeScript, you're not gonna like definitely. There are definitely some nuances, but I mean, it's not much. I mean, I feel like there's a reason why Unity picked it.
Yeah.
To me, it's like the most generic language. Like yeah. I mean, and that's the thing. Like there are functional aspects to it. So like if you like more Lambda expressions, we have Lambda expressions. So it's like even I will typically shorthand a lot of things and eliminate some curly braces just for the sake of typing. And things will just end up being a lot of functional style implementations. So
Cool.
Yeah. ASP. Luckily that's evolved. Yeah.
Sir, I was looking at you when I asked that question. I thought so. That's good. Good. So a lot of possible next steps coming out of this. Kyle, I'm so happy that we're in touch again and thinking about this stuff. And I think there's a lot of follow-up topics to cover, whether it's technical deep dives like this or more playground style sessions, whether it's talking about, you know, why desktop apps might be a powerful tool, or thinking about gaming environments, because I know that's something else that you've been thinking about. So let's keep talking and think about what's worth doing next. And if anybody here has a eureka moment, this week about a topic you'd like to hear more on after hearing what Kyle shared today, please keep those ideas coming.
Yeah, maybe next time we can do an impromptu DAO creation, and that's past the Plutus script stuff. I had a Fund 9 proposal, really with James. It was going to be a collaborative thing, which hopefully we can still do. I'm writing some basic DAO tooling. I'm fighting the urge so hard to like keep it just strictly cryptographic and on Cardano, because I'm venturing into like verifiable proofs and trying to make sure these things can be verified and people can't maliciously act like they're putting proposals on the like on Cardano and acting like that's part of your DAO and stuff. But yeah, I mean, that's making some pretty good progress, and I think I don't know, that'd be pretty cool exercise.
We have to, I mean, so GBTE is only so helpful if the treasury part of it is single signature, right? For that to be able to scale past any small use case, it has to have multi-sig, right? We can't go on without that.
Same with the Cardano treasury. Like, I mean, I don't know if I've mentioned my pool contributes to the treasury, and I pay for a lot of the development because Catalyst just isn't kind of helping us there. So it's one of these things for like even this multi-sig, paying for SIP2, paying for SIP8, that's been really helpful. And right now it's just I have the keys to the kingdom, and if and all the contributors know that I don't like that, so I very much want to set up whether it's just simple multi-sig, but it'd be nice to do a DAO so we can even put out our own bounties, because right now it's more or less like people look to me to create bounties for the library, and I'm like, man, this is not how I want this to happen. Like, I know James and I have this one concept that we always is like, we don't want to be the CEO of our community. That doesn't make sense, right? I want people, like, I have this one contributor's name is Nick. You might have seen some of his stuff. He's come out with like Saturn and Mercury, like the chat app and the minting thing. He's a big contributor, and he wants to actually get his pool to contribute, and I'm like, okay, well, if you're going to contribute, I definitely don't want the keys. So these are things that I like. It just makes more sense that if we are going to be a community, then let's kind of act like one. So
let's timestamp this moment right here and come back to it in 6 months, because this is one of the most urgent pieces of work we have to do immediately, is make sure that these are shared endeavors. I'm glad you're on the same page with that.
And then the next thing you know, we might have a contract where Gimbal Labs and CardanoSharp need to set up their own little work group, multi-sig, budget.
Exactly right. That's exactly.
Yeah, these are the type of tools that I think, especially once we have SSI identity like kind of solved, I think what we can do with this type of tech will move a lot faster, to be honest. I think one of the biggest things holding back dApps is the lack of a user, right? Whether it's a decentralized user or not. So everything is tied to a wallet, which I don't know about you, but I don't walk around telling people my bank account so they know who I am.
Right.
So.
Right. Well, okay, that's a perfect, just to close out today, quick word on the status of the course, the completion token, and the GBTE. I think a lot of people know, congrats, Nelson, for finishing all the assignments. There's a couple of people who are very close to having everything done, and there's plenty of people who are actually eligible already for that completion token if you met a minimum requirement. So the process is there. We're going to move forward with it. The GBTE is ready on Plutus V2, except for getting it to validate transactions in the front end. But during this meeting, I just got an excited message from Abdel Karim that I have to go read. It maybe maybe that Plutus V2 transaction functionality is ready for us. So I'm going to be playing with that. And as soon as Mesh allows us to validate a Plutus V2 transaction with a reference script, we are all systems go to mint the first course completion token and to push GBTE live to mainnet. So super exciting moment right here. The other thing we just have to make a final decision on before that is the art that goes on the course completion token. So hopefully you saw Curtis's post in the Gimbal Labs Discord, voted on one of the options. Juan or Curtis, do you want to say a quick word about that or share any of those options?
Thank you, James. Curtis, go ahead. My microphone is not functional.
Ooh.
Morton's.
Hey, Curtis, for some reason you're breaking up.
So,
Okay.
yeah, so well, we have for the A art, we have 7 people. Then for B, it's 1, and for the C, we have 2 people on this code. So, come and vote.
I'll pull it up right here, just real quick so you can see it, just in case anybody didn't see this yet. Here's the vote. It's in PBL announcements. The current front runner is choice A, which looks like this. I think this is pretty cool for V1 of the art, right? Given the time we've got. So guys, thank you. That looks good. And I think it opens us up to playing around with this in the future in a really nice way. Blue honeycombs got a couple votes. So be sure, if you feel strongly between those, be sure to jump in there. All right. Finally, I'm starting to work on another smart contract project for a mentorship DAO called One Up, One Down. With all we do with PPBL here, I think a lot of people have had mentorship on their mind. So starting next week, I'll just put out a couple of notes on what's going on there and invite collaboration if anybody's looking for something to contribute to. And yeah, looking forward to seeing what happens in the next few weeks as people wrap up the course and we start to get these mainnet contributions going on out there. Really good. Tomorrow we can jump into, we kind of left off last week having talked a little bit about some Plutus V2 functionality. So we can dive into a few ways of looking at that. But I think it'll also be helpful to start with people's questions. So if there's something that you've been working through over the last week or so, and you're stuck or just have some ideas, big picture thinking to share, be sure to come with that. We'll start with that tomorrow before jumping into some exploration of Plutus V2. Anything else before we sign off? Right. Thanks for this session, Kyle. Thanks again. Really great stuff. Everybody. Yeah, that was a blast, dude. See you soon.
Cheers, y'all.